Okay, it's Friday again, and uh, welcome to TGIP episode 5. We have been running TGIP for almost a month, and hope all the videos that I share, all the topics I share that are interested to you and helpful to for you running Pulsar in production. And for those people who don't know who am I, and my name is CJ, and I'm the CEO and co-founder of StreamNative. StreamNative is a San Francisco-based startup that we offer a cloud-native event streaming platform powered by Pulsar and providing fully managed service of Pulsar and as well as developer support if you want to integrating Pulsar into your architecture, infrastructure solution. We also providing free consulting and training as well. And I'm also the PMC member of Pulsar and BookKeeper as well. And I've been along with these two projects for many years and helping customers from running clusters from a few nodes to dozen nodes to like 100 and even thousands of nodes. And I'm also on Pulsar Slack. If you have any questions, if you have any inquiry, you can feel free to reach out to me on Slack or follow me on Twitter. Cool. It's Friday, and I'm really excited about today's topic. Is We are going to take a deep dive into Pulsar architecture for performance tuning. I was doing why I picked this topic is basically um, Devin from Overstock and the Peng Hui from Xiaoping wrote a white paper called Taking a Deep Dive into Apache Pulsar Architecture for Performance Tuning. And so both of the companies have been running Pulsar in productions for a while, and they might have a different experience, but they all share same experience on how to run Pulsar in production, and they basically sharing their best practice and turn those best practice into a white paper. And it's a series of white paper. So this is the first one. It's more talking from architectural perspective on reviewing some of the basic concept and as well as the kind of the architecture and deep dive into individual components to see what kind of performance, what kind of mechanism you have to know in order to tune production workload. It's about 26 to 29 pages. Hope that give you kind of a comprehensive information about how Pulsar work and how you can take that as a guide to find reference, find documentation in Pulsar website to do a performance tuning. And for in today's show, I will basically walking through this kind of white paper. They already did a great job, but I want to add on some of my thoughts and some of my practice before, so to give you um, uh, kind of some add on to this white paper, so you can find a reference in Pulsar website and as well as in the internet to help you success with your business. And as usual, let's get started with some kind of notes. And I will share the notes in the YouTube live chat. You can take a look at the note, and so you can give a glance about what kind of topic we are going to talk today. And uh, if if you want to say hi to me, you also can use the live chat to say hi to me as well. Okay, so let's get to usual. Let's spend a few minutes to see what's happening in Pulsar community in this week. So first thing is we finally we have the first official release on native Go client, and thanks every commuters in the community to make this happen. And you can check it out. It's the tag v 0.1.0. So it's already, I think, even before we cut the first official release, there's a lot of already bunch of companies running this Go client in production. I know Splunk is running native Go client in production, and a bunch of the companies in Asia that is also running native Go client in production. And if you're writing Go applications using Pulsar, so feel free to check it out. And the next thing is it's really excited. We finally start voting the release candidate of 251, and it includes bunch of the very important and critical fixes. If you are using Pulsar and want to be engaging with the community more, the first step you can do is trying to check out this voting email thread and help us verify and vote the release candidate. We have write the release candidate validation process in the Pulsar wiki. So you can go to Pulsar wiki. You can find there's a link called contributor documentation. It's release candidate validation. So you can follow the step and to help us verify a release candidate. So I will also post this into the live chat and you can check it out. So I will encourage everyone help us validate the release candidate. It would definitely help a lot the whole PMC and the commuters on release kind of cutting an official Pulsar release. The third one is I know a bunch of people is using Pulsar integrating with Flink, but the goal for maintaining a Pulsar Flink connector requires both knowledge on Pulsar as well as Flink, and especially the Flink connector really need to tie with the API provided by Flink. So what we have been doing is trying to pushing the Pulsar Flink connector into upstream Flink. So we start a discussion in the community to deprecate the current Flink connector that maintained in Pulsar main repo. That connector was built on a very old version of Flink, and there's a newer version of the Flink connector that is available in Flink ecosystem. So you can go check it out. This connector is already used in bunch of companies' production, so feel free to check it out and run Flink with Pulsar. And if you want to follow the progress about the whole progress of contributing this Flink connector to upstream Flink, you can check out this Flip is what Flink community used for tracking the major improvements, just like Pulsar community is using Pip for tracking large improvements. And so there are a bunch of the Jira issue already created, and there's also pull requests created. So you can go to this Jira issue, and if you wish this connector to be landed in Flink upstream, I would encourage you to make a comment to express your needs. So then Flink community can prioritize the whole review process. And the next thing is I'm really excited to see one of the PIP is coming up, which is called PIP 61 is the advertised multiple address. So right now, Pulsar only allow advertise one address. So this would increasing some of the challenges when you run Pulsar in Kubernetes cluster. So you have to run a Pulsar proxy, and then you have to add a load balancer to for route the traffic through a proxy. But sometimes if you want to leverage machine to machine connections, so you might need using host pod and allowing Parsha to advertise different multiple address will give the flexibility. It will make easy to for Parser to deploy in Kubernetes using host pod. So the implementation is already started and it's contributed by dropping. And please check out the pip. And if you have any thoughts, feel free to give the feedback into pull requests as well as in the mailing list discussion. And the next one is we finally started discussion of separating connectors, adapters in Parser Presto into separate repository. So that would kind of reduce the whole build time of Parser main repo. And it would also, because the developing the core is a bit different of developing a connector on an adapter for Pulsar. So this would reduce the contribution barrier for people to making contributions to non-core components of Pulsar. And the discussion is happening in the mailing list. So if you're on a Pulsar mailing list, feel free to join the mailing list and make a comment and share your thoughts. So this is what's happening in Pulsar community. I'm really excited about all the great stuff is happening in Pulsar community. And okay, next let's get started with the kind of the topic today. As usual, I kind of wrote a Xmine map here. And so in order to kind of do a performance tuning, uh, in a in a just reviewing from an architectural perspective, the first thing I usually encourage people to start is thinking about what is the basic or what is the fundamental data structure. So you have to understand the concepts first, and then next moving into the understanding the architecture. I think we have been talking about Pulsar in many different presentations. We have multiple layer architecture and separating the storage from serving. So you have to understanding how what kind of layers you use what kind of layers in this architecture and how they talk to each other. And if you listen to my previous episode, you might already notice I usually use a diagram that is talking about the network dependency between components. So that is a good way for you to visualize the whole architecture. And then we would deep dive into kind of individual components from a bottom-up strategy. So we go from storage first, and then moving up to broker, and then we'll talk about uh, the communication between broker and bookie, and then to the broker itself, and then to the client. So this would give you kind of a fundamental idea about individual components and also the kind of the critical ideas or mechanisms they use in individual components or in the conjunction between components. So let's get started. I think concept-wise, I think everyone knows kind of top Pulsar has a basic idea is about topic, and each topic is backing up by a distributed log. In Pulsar, it's called managed ledger, and ledger is breaking down into individual. Uh, managed ledger is breaking down into small segments. Each segment is backing up by a bookkeeper ledger, and when you're appending data to a ledger in BookKeeper, the concept is called entry, and multiple mastery form an entry. So this is kind of a basic idea, but I want to emphasize a bit about the whole idea here is the how these kind of uh, concepts are tied together and how these are kind of um, how these concepts are tied together and from a user perspective, what do you need to care about? So I think this is a kind of a diagram I used for some other presentations. So fundamentally, a topic or a partition is an infinity event streams. So it's a pen only event streams. Also, most of the people would call it a distributed log. And within this stream, it's kind of divided into segments. And within a segment is comprised by multiple entries. And entry is interface exposed by BookKeeper. And from Pulsar's perspective, Pulsar clients is dealing with masters. So multiple masters are batched together and compressed into an entry. So what you need, so this is kind of a visualization here, but what exactly what you need to care here is, so you know there's a couple of things, how an event stream is divided into a segment ledger. So how do you control like roll over a ledger to the next ledger? And because that setting would affecting like how you distribute the data and how you what is the frequency you update the metadata. And the you also need to know like how many messages are batched together into an entry. Why you need to care about that is that would decide like how many entries you need to send over the wire from the client to the broker and from broker to bookie, because you want to avoid getting into a situation to make your workloads become request bound or CPU bound. Because if you can batch master as many as possible, then you can be more efficient on transferring those messages from client to a broker in a more efficient way. So that is understanding this kind of layering would help you understanding how to tune individual components. So that is the first thing. And you need to know here is kind of the segment concept we usually talk in a lot of presentation is a logical concept. So it can be backing up by a bookkeeper, it can be backing up by a blob storage, and that is the fundamental concept we used for building out the tier storage. So if you're thinking about tier storage is basically initially a segment is building within a bookkeeper, and when if you keep appending data to an event stream, some of the segments might become old. Then you can offload, you can copy the whole segment into a second tier storage, like in AWS it would be S3, in GCP it would be GCS. And the funny things is here you can even use the schema information to convert this segment into a columnar format segment. And that is something we have been working for a while, and we want to announce this work very soon. And the next thing you need to taking care is, so you understanding this kind of the concept layering, and you would have an idea is how a master ID is mapping. So when you produce a master, Pulsar will give you a master ID, and how this master ID is tied to the this concept. Because the master ID itself, you need to it's used for you to locate where is the master and how I can read the master. So typically, it's three components. That is the ledger ID, basically which segment this message is stored, and entry ID, it means which batch that this message is batched into an entry that is being stored in this segment. And because multiple messages are batched together as an entry, so you will have a field called batch index to identify a message within an entry. And the last one is kind of interesting is because a topic can be a partition topic. So when it's a partition topic, you need to use the partition index to identify which partition this message is produced to. So as part of the message ID information, you would also see a partition index as the information. And how to understand that, let's just walk through some of the quick example here is, uh, let's just give a random example. You have four kind of fields. That is, the first field is the segment. That means this message is stored in segment or ledger 100. And the entry ID is 10 means the message is stored as part of the entry 10. And the next one is the message is the second message in this entry. And 0 means it's going to this partition 0. And similarly, you can figure it out yourself is if this is -1 means there's no batch. So it's just like one message is produced as an entry. If the partition field is, sorry, partition index is -1, that means it's a non-partition topic. And so use this information, you can, if you receive a message ID, you're able to know like what is the you have a rough idea like how this message has been stored within a parser stream. And this would also help if you are using some of the parser administration command like seek. You want to pick a message, you want to get a specific message, you need to provide a message ID. And having this kind of information would helping you like understanding the whole system. And so this is the first concept. When you build this if you have this concept in your mind, then you would know uh, on the broker level, I only need to care about how broker distribute partition across brokers and how a broker break down into segments. So this you will know, okay, these two settings, the partition and segment settings, is kind of belongs to broker. So you need to tune the settings in broker. And uh, for segment, because it's break down into entries, and entries are being stored within a bookie. So you will know how to tune. You will know, okay, bookie is responsible for these both segments and entries. So you know how to tune those settings in the bookie. And the last thing is the the messages are kind of batched into entries. So if you want to tune the kind of the performance and throughput, and that is something you need to figure out where where the batching is happening. Then you will know, okay, it's happening in producer. You go to producer and tune those settings. So having this concept in your mind, that would help you understanding the any future tuning. So that is the first thing, uh, understanding the fundamental data structure. The next thing is you need to understanding the kind of the architecture. I think I already have bunch of the diagram in my previous episode, so I'll just use those diagram to kind of give a bit more context here. Is okay. Oh yeah, I can just use this diagram here. So basically, you would have kind of a client talking to broker, and broker would acting as a client talking to bookie, and broker would as well as talking to metadata store. So that is kind of layering architecture. And in order to understanding this architecture, I use so the white paper give you a kind of a very comprehensive walkthrough, and I would use a strategy here is I would do this deep dive more from the bottom up to all the way up from all the way from bottom at the storage layer, moving up to broker and moving up to client. So this will give you a idea for the individual components. So the first thing we need to take a look at here is on the bookies. Uh, so people will think, okay, bookie is a segment storage, so it store individual segments. Uh, I want to use this time to do some kind of clarification here. Uh, the segment within the ledger within a bookkeeper concept is still a logical concept. In terms of logical means in the whole bookkeeper storage, we don't store individual ledgers as individual files. So there's no physical connection between a segment as a ledger, a ledger as a file. That is the fundamental difference that bookkeeper has versus like some other distributed log system like Kafka. So what exactly bookkeeper is? So bookkeepers store the logs as ledgers, but the ledger is breaking down into individual entries, and each entry is labeling with an auto incrementing like a number starting from 0, and they will send these entries from the bookkeeper client to bookies. So what bookie does is basically entry database. Sometimes I would call it a key value database. And it's a spatial key value database because the key itself is the ledger ID and entry ID. And the value itself is the entry. And the operation provided by the bookie is basically just two operations. One is I append this entry. So basically it's a put operation. I put the key value pair. The key value pair is the ledger ID and entry ID, and the value pair is the entry. And from another operation is read. So basically it's a get. I get the entry by ledger ID and entry ID. So if you think bookie is the key value operation, that would help you uh, understanding a bit how uh, the bookie storage is organized. So just give you a kind of a quick idea is if you have been deploying Pulsar before or deploying BookKeeper before, you know BookKeeper there's two directory. One is general directory, and the other one is the ledger directory. And how uh, how they are used in the whole like the data pipeline. I will try to using a diagram to show the kind of the sequence. So you would have a bookkeeper client. In this case, in Pulsar's case, the bookkeeper client is broker is basically the bookkeeper client. So bookkeeper client was sending a append operation or add operation or write operation to write an entry to the bookie. So the write is basically a put operation. It's basically put a key value pair. The key is the ledger ID and entry ID. So when the bookie receive this entry, what it does, it would first write the entry into journal. So let's just hide some of these. No, I think my bad. I need to hide this. let me hide this. So you can think about a journal. Um, a journal directory is for storing all the journal file. So BookKeeper will open a journal file. So when it receives an append operations, what it does is it basically just append the entry to the journal file. So you might be receiving entries from one ledger. Like in this example, I received 3 entries from ledger 1. And you might also receiving some of the 8 entries from a different ledger, because if you have many topics, that would be mapped into many ledgers. So you just keep appending these entries and keep appending. So as you can see here, BookKeeper doesn't do anything when that doesn't do any organization when it receives the entries. What it does is basically just append all the entries to the journal. So when it appends all entries to the journal, it's kind of a sequential write, so you can maximize your write throughput on disk. And when you finish writing sorry, writing the append all entry to a first journal file, and what it does, it would uh, load over a ledger, load over a journal. So it will basically create a new journal and keep appending all entries to the next journal. So as you can see here, is all writes are sequential. So you can enable everything to kind of maximize the throughput while you are able to still achieve pretty low latency. And so that is kind of the general directory. So you need to know all the general directory are kind of sequential write, and the journal will do everything. So that is the 2 thing you need to know, because that would related to how you tune the performance on the bookie side. And as you can see here, BookKeeper didn't organize any index or storing any index. It's just like sequential write. And how you want to serve read if you don't have any index structure, or if you don't have any mechanism you can look up a given entry. So what it does is basically introduce a concept called a write cache. A write cache is a, a memory within the bookie process. And when you append the entry into journal, at the same time, you will basically put the entry into a write cache. And what the write cache doing is basically 2 things. One is buffering up all the entries, so I can write entries as a large chunk to my disk. The second thing is I can do sorting. I can I can sort the entries in the ledgers order. For in this example, as you can see here, I receive entries from different ledgers, so they're kind of interleaving with each other. And if you put the entries in the write cache, it basically sorts the entries based by the entry ID, sorry, by the ledger ID and the entry ID. So as you can see here, all my ledger one's entries are kind of sorted in order. My ledger two entries are sorted in order. So the benefits of this is when you write these kind of entries into an index structure, you can organize the entries close to each other. So you would have a continuous disk space for this ledger. And when the read request coming in, you can scan this ledger, and you can maximize the scan throughput or read throughput. So when you keep writing, you fill up the write cache. And what the write cache we're doing is you're flushing out the write cache, and basically it would do 2 things. It will building up the index structure. This would including index, and as well as the entry, entry log. So as you can see here, it basically flushing out all entries in the write cache and going into an entry log. And as you can see here, the entry log is kind of writing the entries in sequence. And so this will provide the benefits is when you try to scan a ledger, then you can seek to this position and do a large chunk of scan. So this would be very efficient from disk I/O perspective. And in order for you, in order for Bookie to quickly locate an entry, uh, when the write cache flush out, it need to build out the index. In Pulsar, so in BookKeeper, we have two kind of strategy. One is using the logsdb as the index. So logs basically all the index information are stored in a logsdb. And BookKeeper also provide another implementation called sort ledger storage that basically store each index as an individual files. So those kind of they're very similar, but it's just in terms of in terms of they might have difference on supporting different number of ledgers in the index. LogsDB is more scalable if you want to store store many ledgers within a single bookie. So that is kind of the idea of this ledger storage. So as you can see here, there's a couple points that you need to taking care here is basically how large I need to make my write cache and uh, uh, and how large I want to hold the index in the memory. Because if you don't hold enough index in the memory, that means you need to, when you read an entry or you scan a ledger, you need to keep reading the index from the disk. So that is kind of the main setting you need to taking care of. And in terms of that, let me walk you through using kind of a terminal to tell you how does it looks like in the bookie side. Uh, okay. So the first thing uh, we want to take a look at here is the channel. So in order to tune channel, you need to know first you need to have a good general disk. So you making sure you kind of mounting the disk you use for channel and making sure you configure that. And if you want, sometimes you might using SSD as the general directory. If you want to improving the host throughput, you can create multiple general directory on single disk. So this would ensure you would have multiple general thread on flashing the add entries to the disk. So in this way, you want to configure multiple general directory. And in terms of journal, the other thing you need to take a look at is the journal sync data. Sync data means when you having if you have journal sync data enabled, means before a bookie responds back to the client, you need to making sure all these entries is flushed to disk. So if you have SSD, that's probably fine. If you are using HDD, then if you have a RAID controller usually have this battery back unit. Uh, sometimes it's called write cache. So it will provide a very good F-sync latency, and you can enable F-sync um, for this kind of hardware. But if you don't have SSD, if you just have HDD, and even your HDD doesn't have any RAID cache, then you should consider disable general sync data, and that would kind of improving the whole latency as well as throughput. And so that is the general. The other settings like the general write buffer, general remove from patch cache, I think the default settings are very good, and they have been kind of verified and running in production for many years. So you don't need to worry about that part. And so moving to like the next things is you need to configure write cache. So you really need to be taking care of this configuring this write cache. So by default, it's allocate like a quarter of the whole direct memory you config in your JVM. So you need to making sure here is either disk is you need to align the write cache along with your disk. So if you have a very large write cache config, but your disk is very slow, that means you have a lot of memory buffering in BookKeeper JVM. And if you keep writing, you might be over, uh, because Bookie keep a lot of memory, and you might hit out of memory. So making sure you don't config this into a very large value and cause OOM. So a recommend here is if you are setting your direct memory into a very large number, like for example, some of production use case I've been seeing people config 18 gigabytes, even even like 24, 32 gigabytes for direct memory. And I would recommend setting this write cache to be around 500 megabytes to 1 GB, or even lower. You can do like 200 megabytes to 1 GB, because this would allow you flushing out those write cache to disk and avoid keeping them in memory for too long. And the next thing is, since the whole uh, if your workload is you are going to read a lot of history data, or you want to do rewind, you need to making sure your index is kept in memory. And so this would avoid you going to disk to reload the index. So in order to configure that, you should be configuring the LocksDB block cache. So because by default the bookkeeper the Pulsar settings that used in BookKeeper is the DB ledger storage. So it used LocksDB for holding the whole index. So you want to making sure the index can be held in memory. So usually 1 GB or 2 GB is kind of enough. So you want to tune that setting to making sure you are able to holding that index to avoid you kind of you have to reading the index page each time when you want to do if you want to read entries. Other than that, most of the settings in BookKeeper are kind of well tuned, so you don't need to worry about that too much. But sometimes I also see some of the workloads that becoming CPU bound. Then in that case, you might need to tune some of the number of thread, like the rise, uh, the number of add thread, number of read thread, in order to tune some of the increasing the parallelism for processing those requests. But in most of the time, you just need to taking care of the channel, making sure whether you want to tune F-Sync or not, and increasing the parallelism for general thread, and tune the write cache and also the locksDB cache. That is kind of the main that is the thing you need taking care of the bookie on bookie side. And the next things is once you figure out the bookie, Then the next things you want to moving up to understanding a bit about how the BookKeeper client is the uh, writing data to bookies and what kind of the settings you want to tune there. So for this, first thing you need to understanding the kind of the replication mechanism that used in BookKeeper. And usually, I think people might already know those settings is if you go to broker configuration, you will be able to see the manager ledger settings, and there's a few settings. It's called default example size, default right column size, default add column size. What does that mean is an example is a set, example size is basically how many bookies you use for storing a single ledger. And right column means how many copies of entry you want to be stored. And add column is how many response the client uh, need to wait until acknowledge back to the client. So this diagram just gives you some of the visualization about these settings. So basically, in this example, I use 5 bookies as the example. That means the entries for a given ledger is storing in these 5 bookies, and the column size is the right column is 3, means for a given entry, I will be storing in 3 bookies. And for a column, I use 2. That means I just need to wait until uh, wait for 2 responses. So in order to tune this is you can tune this for scaling up the throughput. That means if I say I increasing the example size from 5 to 7, that means I have more bookies for storing one single ledger. Then you can increase the throughput of a given single ledger. But in reality or in production, most of the people can just making sure the example is aligned with the right column, because when you're running a production workloads, you might have many topics. So your traffic is already spreading across topic. So you don't need using example as a mechanism to scaling up the throughput of a given topic. You usually just use many topics to scaling up many partitions or many topics to scaling up the whole throughput. So that is kind of the idea, and you can tune these settings in the manager um, in the broker, which is called the manager ledger default example size, manager ledger default right column, and default add column. Those settings also can be set per namespace. So if you have a different namespace for different topics, or you can adjust those settings for different requirements. So that is the on the example size. And the next thing you need to take care of is the ledger rollover. Ledger rollover mean control uh, rollover. Ledger rollover control what is the kind of the size of the I need to pull out the diagram again. So as you can see here, kind of a single partition is break down into segments, and ledger rollover is basically control this breakdown. So there are 2 settings here you need to take care of is the max ledger, max entries per ledger. So you control the size of the ledger, and the rollover time, it's control how frequent you want to create a ledger. And if you tune this setting too aggressively, that would result in introducing a lot of traffic to the metadata store. So that might be a bad thing. But if you tune this setting to be too large, that means um, I need to keep a lot of entries in this ledger. And when Bookie do the ledger recovery, it might take much longer time. So you want to find a balance. And this setting is also interesting when thinking about the whole mastery life cycle in terms of like TTL, retention, and garbage collection. So I would try to deep dive into these two settings in a separate session when I'm talking about the whole life cycle of data management for the whole Pulsar system. But for right now, is just remember you need to this setting to be in a balanced state. In most of the use cases, the default settings are fine, but in some of the extreme use cases, like if you have a very small disk, and you might thinking about doing keeping data for some certain duration, and you need to really tune these settings to ensure the whole garbage collection can kick in and reclaim your disk before disk filling up. So I will cover that in a separate session. And the next thing is, as you might know, like in the broker, when the entry are produced, the entry will be kept in an entry cache, and if you want to tune the behavior, you can tune this ledger entry cache. And by default, most of the settings are kind of optimized for default setting and adjust based on the JVM size. And if you have any specific requirements, you can tune these settings as well. The last thing is about read from BookKeeper. And I know I've been helping a bunch of people tune their catch up read use case. And one of the direction people would end up going a lot to the BookKeeper side is going to tune uh, the read ahead cache. Uh, so here, read ahead cache is useful if your read latency is pretty low, because you can read aggressively and then filling up in the bookie cache. But if your initial, if you're the if your disk I/O, if you're using HDD, especially if you're using hard drive, your read latency typically is very high, especially you using the if you read very old ledgers, those are not cached in file system cache. So it will go back to the disk, and this would result in disk sick, and your read latency is very high. If you increasing the read head cache in the bookkeeper side, it doesn't really help because the first read you still need to go back to the disk. So what you really need to do is tune a setting, tune the behavior, how manage ledger reading the entries from bookkeeper. So what you need to go to is there's a dispatch uh, there's a dispatch setting that is controlling what is the maximum number read from bookkeeper. By default is 100. But if you have a very bad disk, like if your disk is HDD, your read latency is like up to seconds, then you really need to tune this read batch size. You can increasing from 100 to 1000 because you want to making sure when you read one time, you get as many requests and put those entries into the entry cache. So you would avoid any stopping between your consuming pipeline. If you if you don't tune this setting, you usually see no matter how you tune the settings in the bookkeeper side or you tune the setting on the consumer side, all your read throughput is never reach a certain point. It will stay in maybe like tens of megabytes per second or 20s of megabytes per second. You will never going up to like 100 megabytes per second. So that is the setting you need to tune if you have a really bad disk. So once you have this manager ledger, The next things is you need to tune broker. But broker, what you need to tune here is really understanding here is namespace and namespace split and shading. Because namespace bundle split would be related how you distribute the topic across your broker. So I actually covered this in episode 2 is about the topic discovery in service URL. And in this, I will just give you a quick idea is in Pulsar, the topic is assigned to broker based on namespace bundle. And right now, the namespace bundle is kind of divided by equally by the hash range. So you sometimes you might see I already config 5 namespace bundle, but all my 3 topics or 4 topics go all the way to the broker one. It's just because unfortunately those 4 topics are assigned to one namespace bundle. So no matter how you split the namespace bundle, it doesn't really helping you spread the traffic. So you will never even you have 4 brokers, you sometimes you might just enjoy the whole throughput of one broker. So in order to address that, in the let me see, I forgot to put that here in yeah here. So in a change back in February, Peng Hui actually introduced a new bundle split algorithm. Is basically distribute the namespace bundle or split the namespace bundle based on number of the topic count. So that is ensure the namespace would have having equal number of the topics. So in this way, when Pulsar distribute the namespace bundle is actually making sure each broker have the equal size of the topic. So if you hit any problem related to namespace bundle split, feel free to check out this pull request called 6241. I'll paste into live chat as well. It's coming up in 260, and 260 will be coming up in a month also. So that is the namespace bundle. And most of the time, you don't really need to config the broker. But sometimes you might be seeing some OOM behavior. OOM behavior could be related a few things like if your producer send the traffic too aggressively, uh, some of the throttling mechanism doesn't kick in. If, for example, if you keep sending message that is sized in like 1 megabytes per second, then most of the throttling mechanism will not be very efficient because most of the throttling mechanism currently are based on entry. So there's a couple approach you can explore is you can set the namespace based rate limiting. You can rate limiting the produce rate, consumer rate, or dispatch rate based on namespace. And those both of settings are configured based on number of entries in number of bytes. And by default, broker would have per channel, per client channel entry based queue based rate limiting. And but this mechanism doesn't work very well if you're sending 1 megabytes per second because uh, it will quickly filling up the direct memory in broker JVM. So you should be considering setting some of the broker rate. That this would be broker publisher throttling and max mastery rate and max bytes rate. So these 2 settings were introducing in 250, I believe, and you can set these 2 settings to based on kind of the capacity that your BookKeeper cluster can serve. Like for example, if your whole BookKeeper cluster can only support 1 megabytes per second, you should consider setting a publish rate around your BookKeeper cluster can support. Otherwise, you would enter a situation is kind of keep sending messages, but your bookkeeper is not able to keep up with the publish rate. That will result in OOM in a broker. So that is kind of the performance you should taking care in the broker side. And the last thing is moving up into the client. Really, at the end of the day, on the producer and the consumer, you kind of only need to care about two queues. In the producer side, all the messages are kind of, when the messages are sent to the broker, they're getting into a pending queue. And this pending queue is kind of limiting what is the maximum concurrent request you send to the broker. And if you want to get a higher throughput, you need to increasing the max pending queue size. And you also need to tune the batching and making sure you send the request in a very efficient way in order to achieve the high throughput. And the last thing, you need to making sure if you are using a customized messaging routing, you want to implement the message router in a way can take the benefits of batching message in together. So that is the producer side. Similarly, on the consumer side, you should be looking into the receiver queue side. That receiver queue is a kind of a background buffer that the consumer fetching messages from the broker side. So if you want to making sure there's no stop between your consumer calling receive and you fetch the data from the broker side, you should try to increasing the consumer receiver queue size. The receiver queue size will also impacting some of the end-to-end latency because if you have a very small receiver queue size, you don't read the message fast enough, then those messages are pending in your receiver queue. And that would cause some delay for your application to consume the messages. So I think this is the way how I walk through the concept to architecture and deep dive in individual components. And Devon in Penghui already did a great job on kind of writing everything down into this white paper. So we encourage everyone go to our website to download this white paper, use that as a reference to find different things to tune. And this X-mind map is also very useful, and it will give you some of the reference how you want to check in tune the performance on your daily basis. And I would upload this X-mind file to TGIP repository, and hope that give you some information, some guideline for your future performance tuning. And that's all for the TGIP episode 5. And if you like TGIP, start our TGIP repo. And if you think TGIP is very useful, and subscribe to our YouTube channel and give give us a thumb up, and we will ensure we'll produce more useful information to sharing more best practice about stuff that we have helping people running Pulsar in production. So hope you enjoy today's show, and hope that is useful to everyone. And thank you, everyone. This is TGIP, and we'll see you in next episode. And hope everyone enjoy your rest of the day. Enjoy the rest of the week. Thank you. Bye bye.